Welcome back to kubectl Explain. Today we will be talking about config maps. A config map is an API object that is used to store data in key value pairs. Config maps are designed for non-confidential text-based data. For confidential data, you would use a secret or something like HashiCorp's Vault, and we'll talk about that later. Now, while config maps are text-based, it is not uncommon to encode small amounts of binary data using base64 or a similar text-based encoding method to be included in a config map. I'm not going to tell you not to do that, but I'm going to sit here and I'm going to quietly judge you if you do. Pods consume config maps as environment variables or as files in a volume. This allows you to decouple your application's container image from its configuration to improve the portability and cloud nativeness, is that a word? It is now, of your application. Now, another warning, because I want to make this very clear, config maps do not provide any secrecy and they should not be used for any confidential data. We have secrets and then external tooling like HashiCorp's Vault for actual confidential data, passwords, keys, connection strings, etc. So let's talk about the why of config maps. And I kind of just mentioned the primary why of config maps, but let's dig a little deeper into it. Part of the 12-factor app manifesto is the separation of config and code. While the exact prescriptions of the 12-factor app may not directly translate to cloud native readiness and running software in Kubernetes, the concepts are sound. Separating your config and code helps ensure that your application is as portable as possible. Common practice across cloud native development is to allow you to configure an app via a combination of the following things: configuration files, environment variables, and command line arguments. This gives the ultimate flexibility to the platform itself on how it provides the configuration for the application. With config maps, you can provide config in any of those three formats quite easily to a pod. Given that even older applications are at least configurable by config file, this means that even in a lift and shift of legacy applications, config maps form a very useful and vital part of your application running on Kubernetes. So let's take a look at what a config map looks like. A config map is, in my opinion, the simplest Kubernetes resource to write. It's certainly about the only resource that I can confidently create on my own without referring to documentation or examples. Apart from designing the resource itself, the config map has just one primary field, data, and that field contains one or more key value pairs. Now, ordinarily, I wouldn't mix literal and file-based key value pairs like you see here in the same config map, but for the sake of demonstration, that's what we're rolling with. You could also create a config map from the command line, like so. So this right here is the command line version of creating the config map that you see beside it. Once you have your config map, you can then access it from a pod as environment variables or as files in a volume, like shown. So for files in a volume, the easiest way to do this is to load the whole config map up as a volume. This will create a read-only volume at the specific path and create every key value pair as a file, with the key being the name of the file and the value being the contents of the file. The advantage to using this method is that if you update the config map, the contents of the volume will also be updated. This will mean that you can reconfigure your application on the fly just by changing the config map. So here's our pod definition that uses a config map as files in a volume. Now, when we combine these two resources, we get three files inside the volume opt-app-config named IP, port, and config properties. And that's why I wouldn't usually mix literal and file-based entries in the same config map, because I don't actually want IP and port as files. So what I could do is get very specific about which files I want to load, like so. So you can see in this version of the pod manifest, we're actually specifying which keys we're going to be using. and we're even renaming the resultant file. So now we're going to end up with a file, just one file, opt_app_config_my.properties, and that will contain the content of the key application.properties. And just like you can load an entire config map into a volume, you can also load an entire config map into a set of environment variables. And you can even reference those variables in your application's entry point, as we see here. However, like before, along with the port and IP environment variables, we're also going to get a variable config.properties with the config file loaded into it. Likely, that is not what we want. So to get around this, like we did with files, we can load up specific keys as environment variables. So let's say the application expects to see the variables myapp_port and myapp_IP. We could configure our pod like so. Here, instead of loading up the entire config map, we're cherry picking which config map keys we want to load into environment variables, and we're also setting a different name for the environment variables to match what our application expects to see. We no longer have an application properties environment variable cluttering things up. Now, very similar to ConfigMaps are secrets. From a formatting perspective and from a usage perspective, apart from some minor changes in naming and verbiage, they are created and used exactly the same way. The major difference is that secrets are base 64 encoded by default. This is not for the sake of encryption, but so that you can have binary secrets like keys. Now, while Kubernetes does restrict access to secrets a little bit more tightly than it does ConfigMaps, they're still not as secure as you may want for your really important secrets. So you might be okay with having like a WordPress database password in there, but you're probably not going to have the password phrase to your root CA in there. For those really important secrets, we still reach out to a more robust and secretive secret management platform like HashiCorp Vault. So ConfigMaps and secrets, they join pods and services to form the holy trinity of Kubernetes resources, consisting of compute, networking, and configuration. Now, there are many more Kubernetes resources that extend these concepts or work alongside them, like volumes, to provide an even more feature-rich platform. And we'll talk about more of those in upcoming episodes.